Hi everyone, this session is delivered in the context of Festive Tech Calendar 2025. Today we talk about hybrid integration with Azure Logic Apps, Kubernetes, and Azure Arc. My name is Massimo Crippa. I'm working as a lead architect at Codit, and here you can find my contacts if you want to connect. All right, so it's clear, let's say, to almost everyone what the focus of hyperscaler is, right? So if you look at Microsoft, for example, almost or all the Microsoft products are cloud-based and they are powered by AI. At the same time, on-premises is still a thing, so there are large amount of businesses that rely on applications that are running on-premises. And those businesses, sometimes they need an integration layer that is closer to their application on-premises. So that integration layer must need on-premises. Why? For example, because there is a limited connectivity. Suppose, think about an application that is on a vessel in the middle of the ocean. They need some local processing needs or networking needs, or they might add some compliance requirements of data residency. So they really need to run on a specific setup on premises. Or another example are low latency requirements. Now, what is the solution for that use case and what might be? It might be Logic Apps hybrid. So, long story short, it means taking the same Logic Apps runtime that you might know from the cloud version of Logic Apps and run the same workflow, the same bits on top of Kubernetes, in Kubernetes. So you might have your own infrastructure and having all the benefit of the Logic Apps way of working. This Logic Apps hybrid is implemented on top of on top of Azure Arc. So we see in a second this. So Arc is the way to connect your local cloud to, your local cluster to the cloud, Azure in this case. This Logic Apps standard, this Logic Apps hybrid, it will provide a consistent management, but also consistent developer experience compared to the version that is in the cloud. So you can have the same way of working and operating your workflow cloud and on premises. And one changes is, for example, in the unit of scale, while in the cloud we are used on the app service unit of scale, and on premises on Kubernetes the unit of scale becomes the pod. All right, so this is how you can visualize. You have on the top the Azure control plane that can orchestrate and control clusters that might be on very different locations, like something on premises for the police, for a specific local requirements, to something on the vessels all over the world, on the aircraft if you want, or also on your laptop if you have enough resources to run this kind of infrastructure. So how does it work? We have to first connect our cluster, our Kubernetes cluster to the cloud. So we have to install some components in our vessel if you want, and then connect to the cloud. Then we can operate our remote cluster from the cloud. So at the point 2, we can impose and define what is the desired state. Then finally, at the point number 3, our cluster will go and connect to Azure, fetch the desired state, and eventually enforce the desired state on the edge. Now, let's look a little bit how the infrastructure is configured, and then we will move to the developer experience. Okay, we have to, step 1 is to start from a Kubernetes cluster. Here on the right, if you want, there are some examples on how I create my lab with AKS, but you can do the same with your local cluster on your local Kubernetes if you want on your desktop. So on the cluster, the next step is to connect our cluster to the cloud by installing the Azure Arc runtime. Here on the right, we can find the command, and at the end of when this command is completed, you will see in the Azure portal a representation, a digital twin of your cluster on premises. This command creates all the all the components that maintain the connectivity between these two worlds. At the end of the day, there will be 13 pods created in the Arc, in the Azure Arc namespace. All right. So pods to manage the configuration, so pods to connect to Azure, pods to propagate logs, pods to managing the billing, and so on. Next step is to configure to install the Azure Container Apps runtime. Why? Because this Logic Apps hybrid is built on top of Azure Container Apps. So it leverages the Azure Container Apps way of working to deploy and scale those workflows. Here, as on the right, you can find the command to install that extension on the Kubernetes cluster. And one of the things that that was to mention is that it requires a connection to log analytics workspace. So the logs of these infrastructure components will be sent to the cloud. And also keep in mind about the auto upgrade, depending which kind of solution you want to propose to your customers, right? So if you want to upgrade your cluster for here in this case, we have upgrade minor version 2 that it goes automatically. Sometimes, especially in production, you don't want to have auto upgrade on because you want to do it in a controlled way. So these are the 29 pods that are created by Azure Container Apps extension. You can see pods to the Envoy proxy. So if you're working with Azure Container Apps, you know that all the communication that are entering your environment that are going through an Envoy proxy. You can see the KDA pods, the pods of logging, and also the pods of Dapper if you're using Dapper. Now, we need to also add some additional, let's say, resources that do not have a physical representation. In this case, are the location and the custom location and the connected environment. The custom location, in my eyes, is to map the model of the RM object model. So when you deploy something in RM, you always need to specify a location, and the Azure ACA connected environment is to match the object model of ACA. In detail, if you look at what those things are at the end of the day, the combination of location plus connected cluster are the digital twin of a Kubernetes namespace. So when you want, we see in a few minutes, when we deploy a workload in a specific cluster, we have to target an environment, and that environment is one-to-one bound to a location. So it's a digital twin of our Kubernetes namespace in our remote cluster. Now, we need also some local resources. While we said that this Logic Apps hybrid is a porting of Logic Apps standard to Kubernetes, but the cloud version of Logic Apps standard, they are depending on some technology that are not really portable. For example, Logic Apps Cloud, it uses Azure Storage Account to persist the history of the workflow and to persist sort of checkpoint when you scale your workflow. And those storage account is not really portable. So now with Logic Apps Hybrid, you can use a SQL on premises, and also you can use an SMB where you can persist your workflow. So when your workflow will be, or if your solution is offline, the workflow can be fetched by that local cache if you want. There is also a support for OpenTelemetry, so then you can, in your cluster, have whatever solution you want to collect the logs and traces and metrics, and also then to visualize with the tool that you prefer. Now, this is the final version of the infrastructure. So on top of the Kubernetes runtime, we have our Azure Arc, Azure Container Apps runtime, and then we will add our Logic Apps workflows. On the top, some cluster with some digital twins, so cluster, locations, and environments. All right. So one important thing is to keep in mind that this is a semi-connected environment. So you can find here on the left some outbound connection. We mentioned some of those, like the Azure Container Apps runtime has to be able to send logs to log analytics. There is also an outbound connection to go and fetch the desired state from the Azure to fetch from the ARM. Okay. And also potentially if your workflows on premises, they are using cloud connections or cloud adapters, you also need that outbound. It's important to know, especially from a security point of view, that there is also an inbound connection. So, and is used by Azure to go and get the run history of your workflow and surface that run histories in the Azure portal. This is also a disconnected can also run in disconnected mode. So what it means, so if my vessel, as I was saying, is in the middle of the Pacific Ocean and there is no connectivity, everything will continue to work on our Kubernetes cluster. The logs will be cached temporarily in the cluster, and then when the connectivity is back again, data will be sent to the cloud. One little mention about the resource consumption. We had around 40, 50 pods, infrastructure pods, and those pods, they consume resources in terms of memory and CPU. And here you can find some example like without any workload running, 7.24 gigabytes of RAM is consumed just for the infrastructure part, and also here 1.1 vCPU without any logic apps running. So if you have a small laptop, also you might have quite a challenge to run this stuff on your laptop if you don't have enough resources. Now, a recap. So we said 42 pods, a certain amount of resources. It's a hybrid infrastructure. We said there is a dependency on the Microsoft version of KDA. Why this? Because we see in a second the way that Azure Container Apps scales is using an HTTP scaler that is in the Microsoft scaler, and also the Logic Apps scaler is also ad hoc, I mean custom tailored for the Logic Apps, and is not coming in the default version of KDA. Now, how we can operate the infrastructure today? Before we just mentioned about the auto upgrade, which I tend to always disable, and there are two auto upgrades: one for the Azure Arc and one for the Azure Container Apps extension. If you disable the one of Azure Arc, you can then go and use the upgrade command to upgrade to a new version. So everything is working fine as expected. But we do not have the upgrade command for the Kubernetes extension. So that's quite a problem. So it's still unclear to me that if you do not enable auto upgrade, how you can keep the Azure Container Apps extension up to date. So this is something that has to be figured out by Microsoft in the coming months. All right, so let's move to the developer experience. If you look at the experience, the developer experience provided by the Logic Apps Hybrid, we can see that we can leverage really the same experience compared to the Logic Apps standard in the cloud. So the way we develop, the way we deploy, observe, and scale our Logic Apps is exactly the same. We can use Visual Studio Code to deploy our develop our Logic Apps or directly in the portal. We can deploy using any tool that interfaces with the Azure ARM Resource Manager. We can observe the status of our workflow using the Azure portal and the Azure Monitor Stack. And finally, we can scale our workflow based on events. All right. So here the scaling technology behind is different. For Logic Apps Hybrid, we are using KEDA, while for Logic Apps in the cloud, a proprietary Microsoft engine, but the way it works is completely the same. Now, how can we deploy our first Logic Apps and our first workflow into using this hybrid way of working? So we have used the same as we're used to do, like create our workflow into the portal. Then at point one, as we said before, our Arc runtime and Azure Container Apps runtime will go and fetch this workflow, this desired configuration from the cloud, and then enforce this configuration on premises. So at the point 3, the workflow that we are creating in the cloud will be fetched and stored on the SMB share on premises, and then a Kubernetes deployment will be triggered. When this deployment is completed, we will have our Logic Apps engine running, and our Logic Apps engine will go and get the workflow and host the workflow and on our Kubernetes. All right, so let's see this in action with this little example. So we are going to have a Logic Apps workflow on premises exposed privately, so not reachable from the outside, and we will manage the traffic by using Azure API management in this case. All right. So now let me bring in the setup. So here I configured before our Kubernetes cluster here. So we suppose that this cluster is on a vessel, and here we have the digital twin that has been connected using Arc. So I can go and check what is the connectivity status, so which kind of agent, Arc agent we are using, and so on. Here we can also double check which version of the Azure Container Apps extension has been configured in my cluster. All right, said that, let's do a deployment. Let's go here or this one, no problem. We just create a new Logic Apps. So let's get Logic Apps from here. Logic Apps. Here we go. And we can create as a Logic App as we are used to. So the only things here we have to, the only change is that we have to specify the hybrid deployment model. I can then give it a name, so festive tech calendar, which region, in this case, Sweden Central, for the metadata. And here we have to select the Azure Container Apps environment that has been created before that represent the namespace in my cluster. Now let's continue and configure some details like the connection to my local SQL here. And then I need to define, to also give, configure also the local SMB share where the workflow will be persisted. Here I just created before, so festive tech calendar. So I created before, let's check it here. On this storage account, I created a file share, and this file share named int share, and this file share will contain a festive tech calendar folder. So let's go. This is fine. I need to add the name, the username, and the password to connect to the share. Here we go. Let's move to the networking. So I don't want to expose this Logic Apps to the outside world, so I will create the ingress private. So only within that namespace will be possible to access, or only within that Azure Container Apps environment will be possible to access this Logic Apps. Let's move on to tags and then create. All right. So I trigger my deployment, and now this is ARM is submitted to the Azure Resource Manager. As we said before, Arc will go and fetch this state. So let's see what happens in the cluster where I have this logic app namespace. And here we should be able to see a pod coming up. This pod is where it will be named Festive Tech Calendar. Let's see, here we are. And it's creating in this pod 3 containers. So a sidecar envoy, a local proxy, and this logic apps base container is where our logic apps engine will work. Now deployment is completed, and also we have our pods up and running. If you go back here on our share, we see that the classic logic app hosted.json has been created. So our logic apps is up and running. So go back to our resource group, and we can find our Festive Tech Calendar logic apps. Now we can go here and just see some details about the container apps and the runtime version. We can find the same experience as in the cloud, where we have schemas, assemblies, and so on. So here are interesting things. So if you see this runtime version not coming up, always spinning here, it's a sign that something goes wrong. If I go and try to create a workflow, it might also fail. So it feels there is something wrong. And actually, in this current version, there is a network policy that is blocking the traffic between within the cluster, within the namespace, the cluster the traffic that is coming from, in this case, some other namespace to the namespace of where our Azure Container Apps environment is created. And let's first fix this problem, and then we will explain later where it's coming from. So I'm just going here and take a different network policy. So I want to edit this network policy that is blocking the traffic. This is deny access envoy admin port, and update it. So let me use a headlamp to do that, which is a way easier to set up. So let me get my cluster here, which is this Packer. I go network. I go on network policies, and there is this deny access envoy admin port has been created by the deployment of our logic apps hybrid. So here the update of this policy has been completed successfully. So I just go back on my namespace where I have my logic apps. Okay, here everything is fine. And now I go and I refresh what I have here. And now you see that finally I'm able to get access to the runtime version. Okay, so I can now go and create my workflow as before. And I can create a stateful workflow. Hello world, if you like. And wait for the deployment. Now the hello world workflow is created. I can go and develop the workflow the way I want. So by using a designer, by using a code first, And if you go and look what happened here in our share, we can see that the same workflow has been hosted, in this case, on premises. And now this workflow will be available in our Kubernetes cluster. So go here. Let's add a workflow that implements some functionality. Let me grab this one. Okay, and I just save it here. And now this workflow will be available here at this address that is coming up in a sec. Okay, this festive calendar, etc., etc. So here, it shows the, let's say, the public domain, but in this case, we need to add internal to this URL to make sure that we can access. So if I just go and call this one from the external, so let's go back to our workflow. Okay, here we see that it's only available with the internal ACA. So in order to get access to this, we should use a sort of debug pod or all of these kind of things. Now, let's see this in action 1 second. All right, so let me move to here, and we just can create an internal test namespace. Okay, I do already have it. So I should also have one debug pod, yes, that I can use to test directly. So let me connect to my pod here and add the workflow address. So let me go and pick it up for you. So let me go on workflows. Here I go to Hello World, go to properties. I can pick up the workflow URL. That's what I want to call. So let me do this way. I'm gonna prepare on this other screen the URL, and I assign it to a variable. Okay, then all right. So I have this workflow URL, and just I Ctrl+C, Ctrl+V, and I just the URL from the user, the Azure portal, and I just add the internal subdomain part of the path, and then I can just curl, and then I will be able to see that I'm calling this workflow locally by a pod that is hosted on my cluster, and I just get my answer back. So this is just like a quick check of the connectivity, that the workflow is hosted on my Kubernetes. So I can exit here. So the test was fine. So I can go then and check the run history here. So now I'm in the portal. The portal will contact the pod, the festive calendar pod, and then we'll be able to just go fetch this history that is persisted on SQL. Now I can go then and check what is the status of our workflow and debug our instance as you are used to do it. All right. So this is just the very quickly the deployment experience. So if I want, in this case, I want to expose to the outside world, I can use an API management with a self-hosted gateway. And because I installed the Container Apps extension, Azure Container Apps extension, I can deploy API management in a Container App by deploying a container app. So I can go and create my container app, and here just deploy in my subscription, in my resource group. I can create my API management self-hosted gateway, and I can then say, okay, I want to deploy this into my Logic App Woodpecker connected environment, and I can then specify which container I want to get from the Microsoft registry. I can add my gateway image, the variables, and so on. So I will be able to deploy this container in front of my Logic Apps. And I already did here. You might be able to find this API management gateway that now has been exposed as external. So I don't have anymore, in this case, the internal prefix. And in this way, I can route my traffic the way I want. I can control how to expose which the Logic Apps without using all of the signature keys that are typical from Logic Apps. And in this case, I might be able to just call it like my warehouse Logic Apps here by using my API management gateway. So here in my Kubernetes, I have a warehouse service and an API management gateway. So here I have my API management gateway, also running behind an invoice sidecar as the API, as the Logic Apps hybrid. Okay, all right. So with this, I can now use a different address to call my API, my Logic Apps workflow via API management, and API management will do the security brokering and protocol mapping between the two worlds, the outside world and the inside world. All right, so this was a short demo. Now let's go back to our deck to better understand what we saw. So here we saw that one Logic Apps is one pod. In that pod we can add, and then Logic Apps container image will be able to host multiple workflow. In this case, we only saw one workflow. The way that we deploy, as we already said, our Logic Apps is the same as the experience that we are used to it. So, and when we deploy that, the RM is a little bit changed because here we are deploying a Container Apps application that then will host the workflow and not a Logic Apps ARM. So the structure of the ARM will be slightly different. In this case, I will be able to specify minimum max replica, the image of our container, and so on. So we saw something there was something wrong with the deny access envoy admin port. So in this case, we just applied the patch. So but now we will go a little bit into the details. So of what we changed. So here is the original network policy. It applies to every envoy component and allows the traffic to the envoy ports, except every port number except the 23200, which is the admin port, and they want to keep the access to that port reserved. And that deny access has one exception, is for the traffic that is coming from the node agent. Now, so this policy is meant to allow all the traffic except the port 200. But yeah, if that's what it means, why there are some traffic was blocked? And in that case, one one of the traffic that is blocked is the communication from the extension API to the envoy. So we were not able to see that traffic coming from the Azure portal. And that's basically because the network policy is really not allowing all the traffic that is coming from different namespaces, because it uses, as you can see, the IP block definition, and that we block cannot only work with the traffic within the same namespace, and it cannot allow traffic from other namespaces. So then we end up to change the policy by adding a new rule that can allow traffic, but instead of using the IP block, it uses a pod selector. In this case, I just say, okay, everything that is coming from an extension API can access to all the ports except the port 23/2000. And also, in this case, I added one more one more pod selector in this case, to allow everything that is coming from the key8sc.microsoft.com/owner app. And those are all the, let's say, the applications that are deployed in the cluster leveraging the Azure Container Apps extension. So in this case, I can allow the traffic between API management and my Logic Apps pod. So long story short, this is a visualization. So if you're working with Azure Container Apps, you know that everything that enters your environment, it goes through an envoy proxy. But in this case, the lines that we have on blue and red, they will not work if that policy is not edited. So in this case, if you want to call the API management, and then from API management, the warehouse service that is exposed as a private traffic, so the traffic will be from the outside world to our envoy proxy to our API management via the port 23,082, and then all the back, that is the port for external traffic, and then API management to contact our Logic Apps. It will call our envoy proxy, the port, in this case internal, so 23,083, and then the traffic it will reach eventually our Logic Apps. So you can see every traffic, external or internal, it always goes through the envoy proxy. That's why we need to also, if you don't edit that policy, we'll have zero traffic going through. So we saw very quickly how to get the run history, and this run history, it goes the fetching of this history from the Azure portal to our cluster. It goes via a load balancer service, so a public IP, and in this case, it will reach our Logic Apps container. That Logic App container, it will host the API that goes and fetch under the root the history from the SQL database. That means that if that pod is not running, so if I stop my Logic Apps pod, if I scale it to 0, it will not be possible to go from the cloud and fetch the history in MySQL. So it will be nice, for example, to have a user interface that can run also on the cluster, just to fetch this data, independently, without relying on this public endpoint, this load balancer, and also to allow some troubleshooting in a disconnected way, if possible. So another things that was to be shared is about isolation or reusing the Azure Container Apps runtime and isolate the application. You can have everything, all the runtime into a single namespace, but then when you try to split the Logic Apps in different namespace, it will not work, because this is not allowed for by the Azure ARM model that we do have. So we can create everything in the cluster separated like this picture, but when we go and try to create a workflow in our Azure ARM and then replicate that state into our cluster, it will not work. This is something that might be coming in the near future. All right, so let's go to some application takeaways. So we can see that we could create our workflow the same way as Logic App Standard. We don't need to build any containers because those containers are hosted, are picked up by the file share and hosted at runtime. So no need to build any container and bake our workflow into a container. The Logic App base image, it contains the runtime, it contains the APIs to interface to the run history, it hosts the workflow, and it contains all the, let's say, connectors that are available on premises. So what about scaling now? So this Logic Apps hybrid deployment way of working, it supports multiple scaling. Let's start from the manual scaling. This is the scaling that is inherited from the Azure Container Apps way of working. So if we do a manual scaling in this context, so we will have a running update with full overlap. What does it mean? It means that we will have zero downtime. So our application will stay 100% fully available, because like you can see here in this picture, if you want to scale from 4 instances, for example, to 6, the new revisions, so the new pods, the new 6 pods will be created side by side to the existing revision. So let's suppose the version with 4 pods. Only when all the 6 pods of the new revision will be available, the previous revision will be terminated. So then when the scale is completed at point number 4, we'll have our desired states to the 6 pods. So you can see that here, yes, it's lovely that allow us a zero downtime, but you have to keep in mind that at point 2 and 3, we need almost more than double the resources available to schedule in that given point in time 10 pods. So you have to be carefully be aware that you need a certain amount of memory and CPU to allow the Kubernetes scaler to just host your pods. Now, there is also a different way of scaling, that is the event-driven. And there are the 2 types of scalers. The one HTTP that is coming out of the box with SCA way of working, and the Logic App scaler. Both of them are leveraging KEDA. One is of the type external in the case of the Logic App scaler, and there is an external push in the case of HTTP scaler of Azure Container Apps environment. So let's start from the HTTP. It's a scaler. It's pretty simple. It monitors the inbound HTTP rate at the envoy proxy. It just monitors the concurrent HTTP request, and it compares per replica, of course, and it compares this HTTP request to the target value. Okay, so if you have more than 10, for example, concurrent requests, then you can start the scaling. In the case of the Logic App scaler, that's the one that we're going to see in 1 second. It will calculate the number of the instances that are required to manage a given workload. Then it will use this value to add more or reduce the number of instances depending on this target value. Okay, so let's see in action. So suppose that this is a situation. So we are having our Logic Apps runtime, our instances configured with 0.5 virtual CPU. Okay, and we can see the amount of requests coming into our workflow on the left, and all of these requests will end up in a sort of web job queue where we can we can understand what are the active jobs. Suppose in this case we have 250 110 jobs that have to be served, right? So in this case, so our Logic Apps pod is consuming 0.5, or we allocated 0.5 pCPU. The target concurrency is 42, so we can calculate that single Logic Apps can manage 21 jobs. Now, by knowing that, we can go to the next step. So we can just look at how many pods do we have. So in this case, 5. So we can calculate our total capacity. In this case, 105 jobs. So in total, our Logic Apps named Alpha with 5 instances can manage 105 jobs. We have 210 active jobs. So KEDA will just calculate the scaling factor, dividing the demand by our capacity. So in this case, the total scaling factor is 2, which means that we need twice the current capacity. And this scale factor, if is less than 1, we can scale in. If it's greater than 1, we have to scale out, like in this case. So as a result, the KEDA will create additional 5 instances of our Logic Apps. So we will be able to manage the existing workload. All right, so this is an example of the Logic Apps scaler in action. You can then follow up with a replica set to understand how the over time the deployment is scaling up and then scaling down. So let's go to the end of this session and just get a little bit the takeaway. So this Logic Apps hybrid is something, is a sort of journey, innovation journey in the making. You saw that there are some gray area that will have to, let's say, be fixed, some features to be added to arrive to the feature parity. But the good message is that it delivers really a consistent developer and operational experience if you want to run your Logic Apps on the edge. And introduce a little bit few changes, so to allow this cloud to edge portability. We talk about that the Logic Apps hybrid is leveraging Azure Container Apps model. It interfaces with SQL on-premises. It requires an SMB share to store workflows. You can use OpenTelemetry to keep your application logs close to your integration platform on the edge. And also it embraces the semi-connected architecture, and with some trade-off that needs to be accepted, like that external load balancer that accept requests from the cloud. Voila, that's what it is. So it's something that is really evolving fast, and I will advise you to just try it out, share with Microsoft your experience, and help Microsoft to shape what's coming next. Thank you for watching. I hope this session was interesting and useful to you.